So today we will be solving this question, number of islands. This is also a graph based question. So let's go through the question first. So given an m cross n 2D binary grid which represents a map of ones which is a land and zeros as water, return the number of islands. So an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. So you may assume all four edges of the grid are all surrounded by water, right? So what this question is saying, right? So let's take a look at the first input. So this is our grid. Uh, so the question says that one are land and zeros are water, right? So how many ones are there? So connecting ones form one land until and unless we hit a boundary where no land is there and we are surrounded by water. So let's think of this case like these all ones, this one, and this one, they form a land. Okay, they form one land, and since there are no other ones, so we'll return one because the lands which are formed by these ones, they are surrounded by water, right? And the boundary itself. So this is one land, and so this is a first case. Then we come to the second input, right? So in this case, what we realize is that these four ones, okay, these four ones are they are forming one line because they are surrounded by zeros. We are only going horizontally and vertically, not diagonally, so we can't connect this one and this one. Okay, so these the 2 cross 2, this matrix, the four ones form one line because they are surrounded by zeros, that is water. This one is also surrounded by water or in all its four directions, right? This is also a line. These two ones are also surrounded by water, right? So this is one line. So one, two, three. There are three lines, right? So this is the idea that we have come up through, like how this is working, right? So how we're going to implement it? The first thing that comes to our mind should be applying DFS, because it is saying that adjacent lands horizontally and vertically. When we do this in case of binary tree where we have to traverse left subtree and right subtree. In that case, same DFS approach is same, right? DFS approach is like traversing left subtree first, then after backtracking traversing the right subtree. Like by recursion we are traversing the whole tree. Okay, so like this, so like that intuition, we are going to implement this problem, right? So let's code it. The first thing that we will do is, first thing we will extract the number of rows and number of columns. Row is equals to uh, grid dot size, column. Okay, so we got it. Now we since we are doing DFS, so one thing that we should keep in our mind is we must have a visited array which stores the how many columns or rows we have visited, right? So since this is a 2D graph, so we have to build a 2D visited matrix, right? So vector. So this is a, since this is a char, so we will implement vector char is visited. Now, how many rows are there? Row and vector char column. Since nothing was visited, so we set all the rows and columns of that matrix is visited to false initially. Now it's time to traverse the whole grid and do the DFS. Okay, right? So for int I equals to 0, I less than row plus I, for int j to 0, j less than column plus j. So if not, if what where we have to do the DFS when there are ones. Okay, so if grid of I and j equals to 1 and that position is not visited or that cell is not visited, so not is visited cell I and j, then we do the DFS, right? So DFS we apply an I through j column and grid and is visited, right? So how many number of islands, right? So we have to calculate this, right? So how we are going to do it? So one thing is like, since suppose this one is first in this first input, we take this one, right? We are starting from there. So we do DFS traversal. We go to this, we go to this, we traverse 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 this. So this is a first DFS traversal that we did, right? And the answer or the output is determined by how many traversals are we doing, right? This is a mind blowing, right? So again, in the second example, again from starting from this one, we do DFS. So first DFS gives us this one, these four ones. Okay. Then again we check whether there is one or not. So these all cells are already visited, so we do not need to visit them again. Then again we come to this one. Okay, this is not visited, and okay, this is also one. So we do DFS, and this is another island. Okay, and again we search for all the elements. Okay, and then we come up through. To these two ones. Okay, so they are also not visited. Since we again do DFS, again we got the land, right? So how many DFS we did? 1, 2, and 3. So DFS. So how many islands would be there is proportional to how many DFS traversal we are doing, right? So we set the count to 0, and how many DFS successful DFS is there, we set to count plus plus and return the count, right? This is done. Now the main thing is, the rest thing is DFS, right? So void DFS. We do row. This I want to keep it short, so I used R, right? This is the, okay. First we have to import the grid. So, grid. So what is the base case, right? What should be the base case? So first we do row and column grid cells. So what should be the base case, right? So since we are traversing inside the grid and we do not want to go outside the grid, right? We do not want to go outside this limit, like to left, to up, to down, right? From there itself, because that is the boundary line that we are checking, right? So the simple check if that's R that we have right now is greater than or equal to 0, yeah, or R should be less than rho, or C, oh sorry, uh, I am doing the reverse case, right? Okay, right, greater than equals to rho, C should be less than 0, or C should be greater than equal to column, or that is already visited, right? C, or the grid value is 0, C, because that is a water, so we need to return nothing, right? Now this thing is done, right? So from this one, how we are going to traverse to right and down, or left and up? So there are four directions, so we need a vector of four directions, right? So vector int del r is equals to, so first thing is, if we go left, is there any effect on the row? Nothing, right? Zero, because we are still on the same row, or on the same level. So if we go up, there is a change in row. Yes, row gets minimized to -1. Again to right, nothing. To down, yes, row changes to the next one. So +1. Same with the column. Wait, we'll see. Again, if we go to left, column changes to -1. If we go to right, so if we go to up, no change in column. If we go to right, column changes. If we go to down, no column changes. Right. So how many traversals we are doing? We are four directions we are traversing, right? So int I equal to 0, I less than 4. plus plus I, and int new row that we got is r plus del r of I, and new column that we get is del c and new column, right? We got this new column, new row, and now we check what we should check. If that new row is greater than 0 and that new row is less than row and that new column is greater than equal to 0 is less than column, right? And not is visited, that new row and new column, and the grid value for that new row and new column should be 1. Then we do DFS traversal, right? New row, new column, then comes the grid, then comes the visited, right? So this is how it should be done, right? We will try to run it. Okay, so there is something is visited. Okay, so there is a spelling mistake here. Now it should run. Okay, again, expression not assignable. Okay, that should be equal to 0, right? We got this runtime error. So the error that occurred here is okay, we are not checking if it is already visited or not, right? So we have to check if we have to visit the current row, right? True. Not IJ, it should be RC. RC. Okay, we have already visited, and I think everything should be fine, right? Again, check it. Let Boolean operation, right? Bool is there. Okay. Yeah. Now it should run, I think. Let's drag. Try to submit it. Okay. So it gets submitted. So we'll check what is this solution, which is 0 millisecond of runtime. He did the same thing, but he used this I plus 1, I minus 1 for the horizontal and vertical and left and right traversal, right? And the rest everything is same. And also, this is a hack that he is using, right? That's why he got 0 millisecond runtime. So this is the thing which I got, or which uh, I I got to know from Reddit, right? So that we can use this 6-7 lines of code, which help us to submit our solution is with 0 millisecond runtime. So again, I will try to submit it. So it will give 0 millisecond runtime. Just see it. So this is, yes. So this is the hack that only works on LeetCode, right? Okay, we should not use it because runtime does not guarantee you that your solution is not very good, because LeetCode sometimes gives different runtimes on the same solution if you try to submit it again and again, right? So that's it for the video. If you do not understand anything, then write down in the comment section, or is there any problem with the solution, or if you have come up with new solution with more better approach, so you can also paste the code down here. I will read it, right? So thank you so much for this.